All right, let's jump straight into this explainer and demystify all those hidden inefficiencies in production and inventory management. Look, whether you're dealing with physical manufacturing or running a service-based process, the fundamental laws of production and operations management, or POM, they totally govern your success. We're going to break down exactly how elite operations managers manipulate these very laws to free up working capital and just completely eliminate systemic friction.
So, today's agenda is broken down into 4 key areas. 1. Measuring the production flow. 2. Uncovering hidden process roadblocks. 3. Mastering inventory cost variations. And 4. Prioritizing with ABC planning. Let's get to it.
Section 1. Measuring the production flow. Okay, so you can't fix what you can't measure, right? In operations management, getting an incredibly accurate reading on your baseline performance is literally everything. The very first metric we need is cycle time. The crucial point here is that cycle time measures the raw rhythm and pace of your unit output. Think of it like the heartbeat of your production line. If a new smartphone rolls off an assembly line every 2 minutes, well, your cycle time is 2 minutes. It doesn't actually tell you how long it took to build that specific phone from scratch, it just tells you how frequently finished products are being completed. Strategically, this is absolutely vital because cycle time dictates your maximum theoretical capacity. It sets the pace for your customer commitments and defines exactly how many units you can promise to deliver in any given shift.
Now, while cycle time tells us the pace of output, throughput time illustrates the complete journey of a product from start to absolute finish. It tracks a single item from the exact moment raw materials enter the process to the moment the final product is fully completed. So, if you want to know how long a customer actually has to wait for their custom order to be built and processed, you're looking at throughput time. For an advanced operation, paying super close attention to the gap between these 2 metrics is absolutely critical. See, a system with a massive throughput time but a really short cycle time, that usually means you have mountains of work in progress, or WIP inventory, just sitting around on the floor. It's tying up valuable cash and space without actually adding any immediate value.
Moving on to utilization. This metric tells us exactly how hard our resources are actually working when they're available on the floor. Let's say you've got this incredibly expensive piece of machinery powered on for an 8-hour shift, but it's only cutting metal for 4 of those hours. Your utilization rate is just 50%, and in operations management, paying for idle time just bleeds capital. But I want to warn you, there's a really dangerous trap here for novice managers, chasing 100% utilization. According to queuing theory, if you push a system's utilization completely to its absolute limit, wait times within that system will actually skyrocket. Variability is inevitable. Without a little bit of buffer capacity, even the absolute slightest delay is going to create massive compounding bottlenecks. So, process velocity. Sometimes debated or questioned as price velocity, this metric reveals our true efficiency ratio by comparing total throughput time to actual value-added time. Think about it. If a product takes 10 hours to move through your entire system, but only 2 hours of that time were spent actively building, shaping, or actually improving the product, well, your process velocity exposes a huge gap. The rest of that time is literally just the product sitting in queues, waiting for the next machine, or being transported across the factory floor. Lean manufacturing obsesses over this exact metric. By ruthlessly analyzing process velocity, operations managers can aggressively strip out that non-value-added time, which accelerates cash flow without actually needing the machines to work a single second faster.
Section 2. Uncovering hidden process roadblocks. Now that we have our baseline metrics, what happens when the operations dashboard starts flashing red? When your cycle times slow down and your throughput times skyrocket, you have to actively go looking for the friction in the system. Specifically, we're talking about blocking and starving. Think of this exactly like a traffic jam. Blocking is a pile-up ahead forcing you to completely stop, while starving is sitting at a green light waiting for a delivery truck that just hasn't arrived yet. In a block system, a worker finishes their task, but the next station is way too full to accept the item. In a starved system, that exact same worker is perfectly capable and ready, but the previous station hasn't sent them anything to work on. Ultimately, both of these represent misaligned capacity between adjacent workstations, and they cause immediate margin erosion because, again, you're paying for idle time.
This is where process analysis comes in. It's the specific tool used to map these operational traffic jams right back to their actual source. And this brings us directly to the theory of constraints, which basically dictates that in any complex system, there is always one singular weakest link, the bottleneck. This one stage has the lowest capacity and therefore definitively limits the entire system's output. By breaking the process down step by step to examine processing times and identify redundancies, managers can pinpoint exactly where the blocking or starving originates. And here's the kicker. Once you find that bottleneck, you don't just optimize around it,
you focus literally all your resources on widening it. Why? Because an hour saved at a non-bottleneck is a mirage, but an hour saved at the actual bottleneck adds an hour of productivity to the entire system.
Section 3. Mastering inventory cost variations.
Okay, let's move to the strategic fix and see how this all builds into the economics of keeping the entire system running smoothly. Because, the most common way managers try to prevent the system from starving is just by relying on inventory. You might naturally be wondering, if starving the system is so bad, shouldn't we just hold massive amounts of inventory just to be safe? Like, if a lack of inputs causes the assembly line to halt, it seems super logical to just buy a year's worth of raw materials up front and stack them in the warehouse. That is the classic just-in-case mindset that so many novice managers fall right into. But modern just-in-time, lean principles teach us that this intuition is dangerously wrong. Holding massive buffers just masks deeper operational flaws and entirely drains your capital.
The real answer lies in carrying costs. These costs financially penalize you for tying up valuable funds and blocking materials in a non-productive form. Every single box sitting in your warehouse is essentially a giant stack of cash that you cannot use for R&D, marketing, or expansion. That's your opportunity cost. On top of that, you're actively paying rent for the warehouse space to store that unsold inventory, paying for security, climate control, insurance premiums, the whole shebang. To put this into perspective, standard industry carrying costs typically run anywhere between 20 to 30% of the inventory's total value annually. So, $1 million of static inventory, that could be quietly costing you up to $300,000 a year just to sit there collecting dust.
This dynamic creates a literal seesaw effect, where ordering costs, that is, the cost of replenishing inventory, and carrying costs react inversely to the quantities you decide to purchase. Ordering costs encompass all the friction involved in replenishing stock. We're talking freight charges, processing invoices, paying receiving labor, managing supplier relationships. If you place tiny, really frequent orders, well, your carrying costs are incredibly low because you have almost no stock sitting around. But your ordering costs go absolutely through the roof due to constant shipping and admin work. Now, if you swing to the exact opposite extreme and place one massive order per year, your ordering costs drop to almost nothing. But as we just established, your annual carrying costs will absolutely explode.
This exact variation results in a convex total cost curve, which represents the ultimate tightrope walk of balancing optimal order sizes. Enter the economic order quantity, or EOQ model. It's a mathematical formula that perfectly calculates the exact order size that minimizes the sum of both the carrying costs and the ordering costs. That absolute lowest point on the U-shaped curve, that represents the exact magical moment where the pain of paying for storage is perfectly balanced with the pain of paying for deliveries. Now, for an expert operations manager, it's really important to remember that EOQ is highly theoretical. It completely assumes constant, predictable demand. So in the real world, modern managers use this lowest total cost point as a strategic baseline rather than some rigid absolute rule.
Section 4. Prioritizing with ABC planning. All right, let's dive into our final pillar and look at how we prioritize all this inventory based on its true consumption value to the firm. Look, not all inventory is created equal. Treating a 50-cent screw with the exact same level of care as a $5,000 microchip is just a recipe for disaster. It's super intuitive to think that physical volume directly equals financial importance. But in almost any manufacturing facility or retail warehouse, the vast majority of physical items you see sitting on shelves, the nuts, the bolts, the packaging materials, they make up about 90% of the total physical volume. The A items, the most critical and complex components, they often represent a surprisingly tiny fraction of the physical space. This is actually a direct operational reflection of the Pareto principle, the 80-20 rule, applied directly to the warehouse floor.
But watch what happens when we flip the perspective from physical volume over to financial cost. That mere 10% of physical volume suddenly accounts for a massive 75% of our total inventory costs. This is the absolute core of ABC inventory planning, which classifies inventory strictly based on its consumption value. The A items, those are your VIPs. Because they carry such massive financial weight, a seasoned manager treats them completely differently. A items might require daily cycle counts, highly secure storage rooms, and incredibly strict supplier service level agreements. Meanwhile, those C items that fill up all the warehouse volume, they're just a drop in the bucket financially, so they might only get a quick visual review maybe once a month.
This data point gives us a powerful aha moment. It represents the ultimate leverage point for a manager's time and resources. Spending equal energy on all inventory is just a super fast track to operational failure.
If you're going to spend your time counting inventory, doing quality checks, or negotiating with suppliers, you absolutely do not waste that precious energy on the 90% of items that only represent a fraction of your costs. You laser-focus your management efforts, your security protocols, and your strict EOQ calculations on that critical 10% that holds 75% of your capital. It's all about working smarter by aggressively managing the economic impact rather than just managing physical boxes.
So, as we wrap up this explainer, I want you to take a hard look at your own projects and ask yourself, where are your biggest hidden frictions hiding? Which 10% of your efforts currently carries 75% of your total value? Because whether you're managing a massive global supply chain or just trying to organize your team's weekly deliverables, these fundamental principles hold absolutely true. Are you being blocked by a downstream process? Are you starving for inputs? And maybe most importantly, are you treating every single task as equally important? Or are you aggressively prioritizing your true A items? Find your bottlenecks, calculate your true costs, and start flowing rather than forcing. Until next time, keep analyzing and keep optimizing.